So these are our scales. I'm actually going to weigh a few different things, and we're going to do a bit of an experiment. So we're going to write our cube. I have a column for cube. You can follow along at home with me. And I'm going to write down what the cube is. So this first cube is a metal. Okay, it's shiny. It's how I know it's metallic. It's also got Cu on it, and it's orange. So there's one element. That's the symbol actually for this element. It's the metal copper. So the copper cube, its mass in grams was 148.5. Okay, and its volume. We'll come to volume in a moment. Let's finish doing mass. Okay, so let's do mass for a few more things. Let's pick another metal. Let's pick a metal called aluminium. You probably know aluminium. We use it, really thin bits of it in foil. So this is it should be a little l. Okay, a little l, that's a symbol for aluminium. So, out of thinking, do you think it's going to be heavier? It's the same size. Is aluminium heavier or lighter than copper? That will tell us if it's denser or less dense. Put it on there. Wow, guys, it's only 44.27. Okay, so that tells us that aluminium is a very, very lightweight metal. Okay, so there's less package in there, atoms in there, than there is here. If you're in chemistry, you get to learn about things called moles. We can figure out exactly how many particles there are. All right, let's try something different. Let's try nylon. Nylon is a type of plastic that ladies' stockings are made of. If I put it on, it is 13.94 grams. Wow, okay. So that's lighter than the aluminium still. Another plastic I have here is PVC. PVC is what a lot of pipes are made out of. Okay, its mass, PVC stands for polyvinyl chloride. It is 25.49 grams. So it's more mass than the nylon. Okay, we have some wood here. I have a hardwood. If I put my hardwood down, you'll find that it is 11.31 grams. I don't know which type of hardwood it is. And let's do this for the pine. So this is a softwood. Put it on. Oh wait, was it 0 when I started? Yeah. Softwood, which is pine. Okay, and it is 7.32. This is all about volume. So what I'm going to be doing here is showing you some different ways that we can measure volume of objects. First one is the simplest method. It's by getting a ruler, and using a ruler we measure regular objects, objects that have the same size or straight sides, but not irregular, not weird shapes. So we look at the size of this. Now this cube with a good ruler is 2.5 centimeters on the side. So one side's 2.5. It should be 2.5 all, but I'm just checking. 2.5 and 2.5. Excellent. So these cubes should all be the same size. 2.5 by 2.5 by 2.5. And because of that, if it was 2.5 by 2.5, we call that 2.5 squared. Times another 2.5, it's now a cube, which is exactly the shape it is. So this is where we get our calculator out and we figure out 2.5 cubed. All right, hey Siri, where's my calculator? Hey Siri, open my calculator. Thank you. Okay, 2.5 times 2.5 times 2.5 equals 15.625. So all of these cubes that we weighed the mass of last time, and a couple of extra ones. Oops, sorry, they're heavy. A couple of extra ones that I didn't measure on screen, but I've measured here. I have their masses. I also measured the mass of 4 different rubbers. One whose origin I don't know. That says yes, no, maybe. It might be yours. I have a pink one that's a brand EF. The Stadler one brand, and this one was a StudyMate one. I know because it has the sleeve on it. Okay, I've taken that off so I can do the next activity. Okay, so we're going to look at, we've got the masses of these objects, we need to find their volumes. And we just figured out that pretty much all these cubes have the same volume. So we have, they're all 15.625 centimeters cubed. Okay, so centimeters cubed is one of our units of volume. It's really handy when you're measuring things in centimeters. Another one, though, when we're looking at things, is actually mils, milliliters. So 1,000 of a litre. If I get a litre and divide it into 1,000 bits, I have a milliliter. So another way of measuring volume when something is an irregular shape, or such as these rubbers have the ends removed, is by actually using a method thought about by Archimedes, an ancient Greek. And he was actually trying to deal with a very difficult issue, which was to figure out if the king's crown makers were actually robbing him of his gold, making a crown that looked like it was gold, but on the inside maybe used a cheaper metal and pocketed the gold for themselves. And what he realized is that when objects go into a liquid, the volume that the liquid goes up is the volume of the object. So we can actually do this with, let's start with a cube that's not too heavy but not too light. Oh, let's just use the aluminium cube. It will sink. Okay, so I get my aluminium cube, and if I first actually, I need to look at it beforehand. So on my measuring cylinder, because it's a cylinder and it has measuring scales up the side, so it's much more accurate than using a beaker. I can be more precise in my measurement. It's 105. So 105 to start with, and this is how we measure volume by displacement. So a cube, its starting volume was 105 mils, and its end volume, when I put the cube in, should go up by the same amount we've just figured out. Okay, so we've got it in there, and now my volume is up here, and the volume is 121. That's what I meant. Okay, so before, after, the other volume difference is going to be the volume of the cube. Trust your calculator. Doesn't fall asleep on me. All right, so I go 121 minus 105 equals 16, volume difference. And what was the volume that we wrote down? 15.625, which is approximately, if I round up with the 6, 16 mils. So 16 mils, 16 cubic centimeters, that's the volume of these cubes. All right, so now we've done that, we know all the cubes are going to be the same volume, so I'm not going to go with them, but let's use this method on the different rubbers we have. So I've been using green water just because it's easier to see. That way it's just a bit easier for all of us. So it's on 98. So we've got 98 mils. We'll do which rubber first? EF rubber. And it's 98 before. Put the eraser in. Eraser, if you're American, we just call them rubbers because they rub out mistakes. Okay, we have to read this at eye level. And remember that water curves, so we want to read the bottom of the curve. And so it is now 100, 2, 4, 6, 8, 108. So 108 minus 98 should be 10. So that's the volume of that rubber. So let's get that one out and try the next one. Next rubber. let's do Staedtler. Staedtler. Okay, so it again, I'll just check because I might have lost some water. 97. Gently put it in. 97. Staedtler. And it is now 113. So 113 minus 97 equals 16. So that's about the same as our cubes. All right, our study mate. This is the last one that I know. Before I put it in, I should measure the volume before. The volume before is 101, just in between the slides. 101 before, 114 after, 114 minus 101 equals 1 is 13, and that was study mate. Now I'm going to do my unknown. The unknown one, I have a hunch it's a study mate rubber. If it's the study mate rubber, it will have the same density as the study mate rubber because they use the same plastic with the same brands. And I can test that theory against my smaller rubbers. Okay, I know this one's a Staedtler because they actually have a little printy thing on it. Okay, but I can do it for the rest of them as well. So let's do the last one. We'll do the volume here. Just a little bit more food dye. Okay, so it's 150, 162. 162 before. Doesn't matter what your volume is before, as long as you know what it is. So 162, and after it's 172, 4, so 174. So that, I believe, is 12. Doing the mathematics in my head. All right, so now I'm going to show you how to do density, but that's volume.